Why is the integral of 1 over x equal to ln of the absolute value of x? Why do we need the absolute value marks? Well, let's think about what absolute value does. So if you have y equals absolute value of x, well, absolute value keeps positive positive and makes negative positive. So if x is positive, it just leaves it alone. If x is negative, it has to find a way to turn it back positive. So we do that with this. If I put in a 2 here, I can get a positive y value. If I put in a negative 2, well, then that just gives me positive 2 again, and I can get a positive y value. So applying that to log, so log of absolute value of x, well, um, same thing. If x is positive, there's no problem. We could just do this. If x is negative, well then, and that would be this graph. So this would be this graph. Okay, if x is negative, well, we can't even take log of a negative number. So this will make sure that when we put in a negative 2, then it turns it positive and it gives the same value that the positive 2 on the right side would have given. And that's exactly what this does. It does what these two do working together. So this is this. Now let's take the derivative of this and this both. Now, if you're watching this video, you know that the derivative of ln of x is 1 over x. If we take the derivative of ln of negative x, well, then by the chain rule, it would be 1 over negative x times the derivative of the inside function. It's still going to give us 1 over x. It's the same for both of them. So if the derivative is the same for both of these, then in general, 1 over x is the derivative of ln of the absolute value of x. So we can conclude that if the derivative of the absolute value of x is 1 over x, when we take the integral of 1 over x, we're asking ourselves, what is the function that this came from? And if we just do this, we're only telling half the story. To get the most general answer, we need to have the absolute value marks on, so we're not eliminating half the story for no good reason.